Our new product, HTG Container Greenhouse, makes agricultural production by creating its own ecosystem, without being affected by the external climate between -30 degrees and +45 degrees. We created the greenhouse cabin by laying the steel cargo container in ISO standards with 40 mm facade panels. We increased the climate and hygiene control by separating the 3.50 square meters engine room and the greenhouse production area with a glass door. HVAC, our integrated system air conditioning system, heats, cools, and ventilates the greenhouse. Our heat conversion device provides air conditioning at 6 to 7 degrees without consuming electrical energy. With the air ducts we have laid on the ceiling, the air is evenly distributed inside the greenhouse. By determining the operating temperature of the HVAC system, we can reduce or increase the operating levels of the fans and aspirators in the suction discharge lines between 1 to 5. Working with automation, sensor data in our main menu, temperature, CO2 humidity, pH, electrical conductivity, water capacity of the tank and how many degrees the HVAC system is set, the level of the fertilizer tanks and the working time are automated with algorithms in our fully automated fertilizer dosing system. It is monitored and recorded with advanced technology sensors, and the relevant system is activated when it exceeds the optimal values. Our disinfection system with micropowder makes the greenhouse sterile when new production starts. It also provides effective intervention in cases of illness. The disinfectant unit can operate for the set time when the ignition is pressed manually from the screen. We produce our LED lighting system for each greenhouse according to the lighting needs of the plants to be produced in the greenhouse. We can turn on lights of different wavelengths separately at different times, and dim their intensity from 10% to 100%. Our closed-circuit pressurized irrigation system distributes irrigation water equally to plant channels. The water returning from the irrigation is filtered and treated, and enters the irrigation tank again. Additional irrigation can be done at any time by using the button in manual mode. We can see the graphs of our sensors here and view the historical graphs here. On the other page, we can see the ECPH and the level of the water tank. We check whether the digital and analog inputs and outputs give signals. In the settings section, there is a place where we can enter the value range where the sensors can be calibrated. We can see the automatic working time here. To reset after planting, it is sufficient to confirm the warning screen that appears after pressing the reset button for 5 seconds. With the daylight transfer system we developed for the first time in the world, we increase the intensity and area of influence of sunlight and take it into the greenhouse. While this increases the flavor of the food, it also reduces the electricity consumption. Again, with a first fire early warning system in container greenhouses, the sensors detect the fire in 30 seconds and the electricity of all units is cut off. Afterwards, the covers of the panels that suck into the ventilation ducts are closed within 20 seconds, preventing the entry of oxygen into the greenhouse and extinguishing the fire. We have made the container, which is the cultivation area, completely closed, well insulated and climate controlled. In this way, it is not necessary to spend much energy for heating and cooling. With our specially designed plant shelves, we ensure that the plants placed at certain intervals benefit equally from a single lighting source on all floors. While reducing energy consumption, we increase the number of plants per m2. Our plant shelves also allow plant slabs, which are solid plant growing media with the root depth required by the plant, to be placed. Solar tunnel system, with innovative applications in which natural light is carried into the greenhouse with solar tunnels, the lighting needed by the plant for photosynthesis is met to a large extent from a renewable sunlight source instead of artificial light. The proliferation of sunlight into the greenhouse environment reduces the use of electrical energy in greenhouses and therefore carbon emissions. In our vertical farm, the daylight taken into the greenhouse with the solar tunnel is measured with the PAR sensor, and the missing part is supplemented with LED lighting. The energy of LED lighting and other systems is produced by solar panels. By installing a 5.4 kilowatt-hour solar energy system on the roof of the container greenhouse, the greenhouse produces 90% of the energy it consumes. We simulate the sunrise and sunset in the lighting we make using specially designed lighting LEDs. The plant, which suddenly goes from sleep to light, is prevented from getting stressed. By providing the wavelengths required by the period in which the plant is in the necessary proportions, energy consumption decreases and plant growth accelerates. Productivity and quality increase. 4 different lights are dimmed in 4 different channels according to the most useful wavelengths in photosynthesis. Independently from each other, it meets the plant need at an optimal level by increasing or decreasing according to the amount of light received by the sun tunnel.